Students, now we will solve the examples related to what we have discussed in theory part. So in theory we have discussed till now what is unpolarized light, what is polarized light, what is plane of vibration, what is plane of polarization, and after this we have discussed how we can produce plane polarized light with the help of polarizer as well as by the method of reflection. So now we will solve few examples so that these concepts becomes more clear. Concepts will become more clear to you. So go to your question sheet and solve. Read out the question number 1 in your question sheet. Question number 1 is two polarizing sheets have their polarizing directions parallel. Means we have two polarization sheets whose path axis is parallel to each other. Determine the angle by which either sheet must be turned so that intensity fall to half of its value. So what he is saying in question number 1, so we are discussing question number 1. So answer of 1 or solution of question number 1 is we have two polarizing sheets. This is P1 and P2. These are two sheets. This is P1 and P2. Light is coming from this side. It is passing through this, and here we are observing the intensity I1. So what is happening initially? Here we have theta equal to 0. Path axis is at 0, and here theta is at 0. So initially what they are saying, two polarizing sheets have their polarizing directions parallel. So parallel means they are parallel to each other. Here path axis of P1 is at theta equal to 0, and again for P2 it is at theta equal to 0. So here intensity is suppose I1. Now we have to determine the angle by which either sheet must be turned. So suppose here I am assuming that we are turning this P2 by an angle. So we are turning this by theta. So now this P2 sheet, it is at 0 angle and this is at theta angle. So here this intensity I1, it will become, suppose here intensity, initial intensity was I0. So now when the path axis of this is 0, path axis of P2 is theta, so difference between these two path axes will be theta minus 0 equal to theta. So what will be intensity I1? I1 will be equal to I0 cos square theta. So by using the Malus law, this I1 equal to I0 cos square theta. Initially here intensity at this point and intensity at this point was equal when the path axis of this P1 was exactly equal to path axis of P2. But when this P2 is rotated by an angle theta, then intensity becomes here I1 and this I1, and intensity here I0, they will be related by Malus law. This angle theta, this is the difference between this is the angular difference between the path axis of P2 with respect to P1. So this is theta. Now he is saying that this I1 is equal to half of initial intensity. This is I0 by 2. So this will be cos square theta. So what will be the value of cos theta? Cos theta, it will become plus minus 1 by root 2. So from here theta can have values equal to plus minus 45 and plus minus 135 degrees. So this is the answer of question number 1. So we can rotate this P2 by an angle plus minus either clockwise or anti-clockwise, plus sign clockwise, minus sign anti-clockwise. So if we rotate this P2 by an angle of 45 degree or 135 degree in clockwise or anti-clockwise, then this I1 will become equal to I0 by 2. So this is question number 1, and answer of question number 1 is plus minus 45 and plus minus 135. ठीक है, समझ में आ गया? ओके, नाउ वी गो टू क्वेश्चन नंबर 2. Now we will solve question number 2 of question sheet I have already provided you. Question number 2 is sun rays incident obliquely on a pond are completely polarized by reflection. So sun rays are coming and they are incident on a pond and they are completely polarized after reflection. Now we have to find out the elevation of sun above the horizon. So what we have here, we have here sun. Suppose this is sun, this is emitting a light and this light is falling on the pond. Suppose this is pond. This is pond here. So this is pond here. Light is coming from the sun. It is incident obliquely. And here on this side, we are getting, on the reflected side, we are getting plane polarized light. So basically, first we have to understand what is the plane of incidence. So plane of incidence is this one, this board. The plane of this board is acting as plane of incidence for question number 2. So here sunlight is coming. This is reflected light. This is normal. So a plane carrying the plane which has incident ray, reflected ray and normal to this, that plane is known as plane of incidence. So this is plane of incidence. So if this is plane polarized light, it means this angle should be equal to theta p. Angle of polarization or Brewster angle, this is theta p. This theta p, from here one can observe that if this is theta p and here what we are getting plane polarized light. So automatically electric vectors which are moving like this, they can only pass. Electric vectors which are like this, they are getting pass, and these electric vectors are perpendicular. These are perpendicular to plane of incidence. So basically these components are representing the S polarized light, and the components which electric components which are parallel to plane of incidence, they will not pass through this. So if light is incident at theta p angle on the pond, then the reflected light will be plane polarized light, and this will be S polarized. This will be S polarized. So we have to calculate, first we have to calculate this theta p. This theta p will be tan theta p equal to N2 by N1. N2 is the refractive index of water and N1 is the refractive index of air. So this will be equal to, this will be N2 upon 1, or this will be N2. N2 is equal to refractive index of water with respect to air, and this is equal to 1.33. So from here, this theta p, so take the inverse of this. So theta p will be tan inverse 1.33, and with the help of calculator we can find out that theta p is equal to 53 degree. Now we have, but this is theta p, but in the question he is asking to calculate this angle. Basically with the horizon, what angle this sun rays is making. So basically in this question you have to calculate the elevation angle of the sun, and this will be the elevation angle. Suppose this is theta e. So this theta e, elevation angle of the sun, this will be basically this will be 90 minus 53 degree. So this answer will be equal to 37 degree. So by calculator you can find, first you can find out this angle of polarization, and from this angle of polarization we can calculate the elevation angle of the sun. Why I am choosing 90 minus 50? If we draw this triangle here, then this angle is 90 degree. Sum of this and this is 90 degree. So theta e is equal to 90 degree minus 53 degree. So this is equal to 37 degree. So this is the answer for question number 2. Now come to question number 3. Now come to question number 3. Read out. First read the question number 3. Light is incident from water. Refractive index of water is 1.33 on the glass, whose refractive index mu is equal to 1.5. So light is incident from water on the glass plate. So what we have a glass plate which is placed inside the water. Light is traveling through water and it is falling on the glass plate. Now we have to find out the polarizing angle for the boundary separating between water and air. So here in this case, polarizing angle is, so we are solving question number 3. Here polarizing angle will be tan theta p. Tan theta p is n2 upon n1. N1 is the first medium refractive index. Here this is water, so light is first traveling in the water and it is falling on the glass plate. So this is the refractive index of glass plate, refractive index of second medium, first medium is water. So this will be equal to, basically glass refractive index is 1.5 and refractive index of water is 1.33. So 1.5 divided by 1.33, this is equal to 1.1278. So this is tan theta p. So here theta p will be equal to tan inverse 1.1278 and its value comes out to be 48.4 degree. 48.4 degrees the answer of question number 3. So basically what we have a glass, in this question we have a glass plate inside the water. So refractive index of water is this one, 1.33. Now light traveling through this medium is falling on the glass plate which is acting as a second medium. So refractive index of the glass plate is here. By using this formula for polarization angle, tan theta p is equal to n2 by n1. We have calculated the value of theta p, that comes out to be 48.4 degree. So this is question number 3. Now come to question number 4. So here now we will solve question number 4. So first read what is question number 4. Go through question number 4 first. A system of 3 polarizing sheets. We have a system of 3 polarizing sheets intercept a beam of initially unpolarized light. So we have 3 sheets P1, P2 and P3. Here we have 3 sheets. This is P1, P2 and P3. We have 3 polarizing sheets. Intercept a beam of initially unpolarized light. So from here an unpolarized light is incident on the first polarizer. Suppose intensity of unpolarized light is I0. The polarization direction of the first sheet is parallel to Y. So polarization sheet, the path axis of this polarization sheet is along the Y axis. So I assume that for this theta is 0. The second sheet is at an angle of theta counterclockwise from the y-axis. So I am not aware about this. So this is oriented at theta with respect to this first sheet, path axis of first sheet, and these two are making an angle theta with respect to each other. This is along y cap direction. Now, while the third sheet is parallel to x-axis, so basically this is parallel to x-axis. If this is in y cap direction, this is in x cap direction, so corresponding theta will be equal to 90 degree. So first, the path axis of this is at theta equal to 0 degree, this is at theta degree, this is at 90 degree. This is the orientations of the path axis of 3 polarizers which are given in this question. The intensity of light emerging from the third sheet. So from here, whatever light is emerging, that is, so basically here I will have I1, here I will have intensity of light I2, and here this is I3, and this is given I3 is equal to 11.52 divided by 100 of I naught. This is 11.52% of original intensity. Now we have to determine the angle theta, in which direction is the emerging light polarized. So first question arises that the direction in which the emerging light. So emerging light is here in this section. Intensity of this light is I3 here. Path axis of this is in x cap direction. So automatically emerging light will be polarized parallel to the path axis of a third polarizer. So polarization here is along. So polarization of emerging light is along x cap direction. So this is one part. And in the second part, we have to find out the value of theta. Value of this theta we want to find out. So first, we will write down the intensity of I1. So this I1, what will be the value of I1? This is very important here. We have unpolarized light of intensity I0 passing through a polarizer. When unpolarized light passes through a polarizer, then intensity becomes half. So automatically I1 will be equal to I0 by 2. This is first part. Second, now this I0 is passing through this second polarizer and emerging intensity is I2. So with the help of, now this is plane polarized light. This is plane polarized light. Now this plane polarized light is passing through P2 and its intensity will become I2. So we can find out I2 with the help of Malus law. So I2 will become I1 cos square. The angular difference between the path axis of these two, angular difference between the path axis of these two is theta minus 0. So this is cos square theta. Now this I2 is also plane polarized light, and this plane polarized light is incident on third polarizer. When it comes out of it, its intensity will become I3. So its intensity will become I3. I3 will be equal to I2 cos square 90 degree minus theta. So what is the angular difference between the path axis of P3 and P2? This is 90 minus theta. This is 90 minus theta. So cos square 90 minus theta. This will be I2 sin square theta. So I substitute I3 is equal to I2 is equal to I1, or this will be equal to I1 sin square, I1 cos square theta multiplied by sin square theta. Here this cos 90 minus theta is sin theta, so this will be I1 cos square theta into sin square theta. Now I1 is equal to I0 by 2, so I replace this I1 by I0 by 2 here. Now what is given in the question? That emerging intensity is 11.52% of original intensity. So in place of I3, I will write this will be 11.52 by 100 into I0. So now we have to solve this equation to find out the exact value of theta. So I will convert this into a quadratic equation. For this, I will write the sin square theta. I will replace this sin square theta by 1 minus cos square theta. And my final equation will become cos to the power, this will become cos to the power 4 theta minus cos square theta plus 0.2304 equal to 0. So basically this is a quadratic equation in terms of cos square theta. So by solving this equation, by using the basic formula, Sridharacharya formula, we can find out the value of cos theta. Cos theta from here comes out to be plus minus 0.8 or 0 or 0.6, and from here theta value will be 36.87 or this will be 53.13. With the help of calculator, you can find out these angles. So basically what we have done for the first part, when unpolarized light is passing through the polarizer, so its intensity will become half, so I1 will be I0 by 2. Now we have plain polarized light which is passing through the polarizer P2. When it will pass through the P2, basically it will follow Malus law for intensity, so I2 will become I1 cos square theta. Theta is the difference, angular difference between the path axis of P1 and P2. This is theta. Now when this plane polarized light again passes through P3, then again I will apply Malus law and it will become I3 equal to I2 cos square 90 minus theta. And here 90 minus theta is the angular difference between the path axis of P3 and P2. So basically this will become I2 equal to, I1 will be here, I1 is replaced by I0 by 2, and this number is given in the question. So by solving this equation, we find out that the theta the angular position of the path axis of second polarization can be either of this, either it will be 36.87 or it can be 53.13. This is question number 4, very important from exam point of view. All the 4 questions which I have discussed, they are given in assignment number 14. You can check or you can find out these questions in the question sheet I have already provided you for this class. Now come to question number 5. Now come to question number 5. In question number 5, 3 polarizers P, Q and R are placed parallel to each other. Means we have 3 polarizers P, Q and R. We have 3 polarizers P, Q and R placed parallel to each other with their planes perpendicular to the z-axis. Q is placed between P and R. Q is placed, this is Q and this is P and this is R. So Q is placed between P and R. Initially polarizing directions of P and Q are parallel. So basically their path axis is parallel. So whatever intensity will be here, same intensity will be here. But that of R is perpendicular to them. If they are at 0, this is at 90. So automatically on the emerging side, intensity will be 0 because this will become cos square 90 here. Cos square 90 will be 0. In this arrangement, when unpolarized light of intensity I0 is incident, so here unpolarized light of intensity I0 is incident on P, the intensity coming out of R is 0. Here it will become I0 because this and this are parallel. So here it will be I0 by 2. Again they are parallel. So here it will be I0 by 2. But at the same time Q and R, their path axis are perpendicular, they are given. So here intensity will be 0. This is given in the first part. The polarizer Q is now start rotating. So we start rotating this. We are rotating this Q about the z-axis, plot the intensity of light coming out of R as a function of angle of rotation. So what I am assuming that this is at angle, path axis of this P is at 0 and path axis of this will be automatically at 90 degree. P and R is fixed, Q is rotating at some instant of time. Suppose its path axis is at an angle theta. This theta can have any value from 0 to 360. So basically I am assuming this an arbitrary angle. So here intensity, when I0, unpolarized light of intensity I0 passes through P, its intensity will be I0 by 2. But now here intensity, now path axis of P and Q, their relative angular difference is theta. So here we will have intensity I2 and here we don't have intensity 0, rather we have I3. So here I2 will become, here intensity here, this will be I0 by 2 initial intensity and cos square theta. Cos square theta. At the same time, when I am calculating I3, this I2 will act as the initial intensity. Here this I2 is initial intensity, this is the emerging intensity. So I3 will be equal to I2 cos square angular difference between these two. So this will be I2 and this will be cos square 90 minus theta. Now substitute this a value of I2 here. So this will become I naught by 2 cos square theta. And this will be equal to I3. So this will be the expression of I3. Now I want to, in the question they are asking us to plot the intensity of light coming out of R as a function of angle of rotation. So this cos 90 minus theta, this will be sin theta. So I3 will become I naught by 2 cos square theta, and this is sin square theta. So we have to plot, what we have to plot? We have to plot intensity I3 as a function of theta. So first we will check intensity at 0 when theta is 0. So sin 0 will be 0 and I3 will be 0. This will give us I3 will be equal to 0. When we are using 45, theta equal to 45, and I choose theta equal to 45 degree, then cos theta, cos 45, it will be 1 by root 2. So cos square theta y will be equal to 1 by 2. This will give 1 by 2. So here I3 will become I naught by 8. If we place theta equal to 90 degree, then you will find out that this cos 90 will be 0 and I3 will be equal to 0. From these three values, we can conclude that we will have this type of intensity variation. So here we will have pi by 2, here we will have 0, here we will have pi by 4, here we will have pi, 3 pi by 2, and here we will have pi, and this maximum intensity, this will be at 45 and this will be I naught by 8. So this is the intensity plot of I3 as a function of rotating angle of this cube. So this is question number 5. This is the solution of question number 5. In this way you can solve this question, question number 5. Now come to the last question, question number 6. These are very important questions from exam point of view. You will find out many times they are asking questions related to Malus law in the exam. So in question number 6, what you have, 4 perfect polarizing plates are stacked. So here we have 4 polarizing plates, P1, P2, P3 and P4. P1, P2, P3 and P4. 4 polarizing plates are stacked so that the axis of each is turned to 30 degree. If this is at 0 degree, this is at 30 degree, this is at 60 degree, this is at 90 degree. This is given with respect to the preceding plate. The last plate is crossed with the first. So basically this is at 0 degree, this is at 90 degrees. So basically P1 and P4, they are crossed with respect to each other. How much of the intensity of an incident unpolarized light? So incident light is unpolarized light and its intensity is I naught. Okay? I naught is transmitted by the stack. So here whatever intensity, that will be I1, sorry, this will be I1. Here intensity we will have I2, here we will have intensity equal to I3, here we will have intensity I4. So I1 will be equal to, how much intensity will be? Unpolarized light is passing through P1, so it will become half of the initial intensity. Then I2, this I2 will be I1 cos square, this will be I1 cos square angular difference between these two. So this is 30 degrees. So this will be I1 cos, this will be I1 is equal to I naught by 2. So this is cos square 30 degree. Now come to I3. I3, basically I3, for I3 this I2 will act as initial intensity and final transmitted intensity is I3. So I3 will be equal to I2 and this will be equal to I2. What is the angular difference between P2 and P3 between their path axis? This is 60 minus 30. So again this will be cos square 30. If we substitute I2 here, this value of expression I2, this I2 value here in this expression of I3, then this will become I naught by 2 cos to the power 4 30 degree. Now come to I4. I4 is the intensity. For I4, this I3 will act as initial intensity. So first I will write this. This will be I naught by 2 cos to the power 4 30 degree and cos square theta. Cos square theta, here theta is the, again I am saying, every time I am saying this is the angular difference between the path axis of P4 and P3. This is difference 90 minus 60 30. So this will be cos to the power 2, the cos square 30 degree. So here we have cos to the power 6 and 30 degree angle. So if you substitute the value of cos 30 degree is under root 3 by 2, then you will find out that this comes out to be 27 I naught by 128 degree. Sorry, 27 I naught by 128 not degree. This is I4. This is the final answer. So in this way, I have solved all the 6 problems I have given you. Go through these questions yourself, solve these questions, and then we will meet in the next lecture. Thank you.